Alright, now we have another combustion reaction. Instead of ethylene, we now have ethane in place. C2H6 contains 2 carbon atoms and 6 hydrogen atoms within each individual molecule of ethane. And it is reacting its ethane gas, reacting with molecular oxygen in its gaseous form, and they combust to form carbon dioxide gas and liquid water. And like we've seen in previous examples, this chemical equation is not balanced. How can we tell? Well, here on the left-hand side, we have 2 carbons. On the right, there's 1 carbon. On the left, we have 6 hydrogens. Here on the right-hand side, we only have 2 hydrogens. Here on the left-hand side, we have a total of 2 oxygens. On the right-hand side, we have 2 plus 3 oxygens. So at this point, none of the elements present are properly balanced. But like we did in the example with ethylene, whenever you see this where you have several somewhat complex molecules involved, it's good to save the element that is in a molecule by itself for last. Because you can just tweak this to change the number of oxygens without having any other side effects on the number of carbons or hydrogens. I am going to first balance, like we've done before, the carbons and the hydrogens, which are going to have implications on the oxygens. Because if I change the number here, it's going to change the number of oxygens, but luckily I have this dioxygen molecule on the left that I can tweak at the end to balance the equation. So let's start. Last time we began with carbon. Let's start with hydrogen this time. So over here I have 6 hydrogens on the left-hand side. On the entire left-hand side, I only have 6 hydrogen atoms. On the right, I only have 2 now. So if I want to have a total of 6, I would multiply these 2 by 3. So now I have 3 water molecules. Each of them have 2 hydrogen atoms. So I am going to have 6 hydrogen atoms present on the right-hand side. Now, let's go to the carbon. Remember, I am saving oxygen for last. Carbon on the left-hand side, I have 2 carbons. How many carbons are on the right? Well, right now I only have 1, but I can change that very easily. Instead of 1 CO2 molecule, I can have 2 molecules of carbon dioxide. And so now my carbons are balanced. 2 carbons at both sides. And now, let's move on to the oxygen atoms. At this point, I will go ahead and illustrate this in a nice mauve color. At this moment, on the left-hand side, I have 2 oxygen atoms. However, on the right-hand side, there are 2 multiplied by 2, which gives us a total of 4 oxygen atoms. And then I have 3 H2O molecules. Each of them have 1 O2 atom, so 3 times 1 equals 3. So this is going to be 3 right over here. On the entire right-hand side, now I have 7 oxygen atoms. And on the left-hand side, I only have 2. So what can I do here? What number can I multiply by 2 in order to reach 7? 2 multiplied by which number equals 7? Well, if we think about it, 2 times 3.5 gives us a total of 7. Remember, I have 2 here. I am saying that 2 times a certain number is equal to 7. I want to reach the sum of 4 plus the 3 together. I will multiply it by 3.5. And now, I have a total of 7 oxygen atoms present on both sides of my chemical equation. But like we've seen in previous videos, it is not standard to just leave a 3.5 here. It's kind of this weird notion of 3.5 molecules. We like to have whole numbers here. How do we change to ensure all coefficients in front of our molecules are whole numbers? Well, we could just multiply everything by 2. Then this thing will become 7. This will become a 2. This will become a 4. This is going to become a 6. Let's just do that. I will rewrite the entire reaction. So now, I have my ethane molecule. And I won't write actually what state it's in, just to save some time. Plus some amount of molecular oxygen gas. They undergo combustion, and they yield. So these are the reactants. The resulting chemical products of this reaction are carbon dioxide gas and liquid water. So let's take a look here. You go ahead and multiply. If you say that there was a 1 out here before, we're going to multiply that by 2 to get 2. We had a 3.5 here. Multiply that by 2. You get a 7 here. We had a 2 right over here. Multiply that by 2. You get a 4. Once again, I am just multiplying all the coefficients by 2, just like you did in an algebraic equation in your algebra classes. And then 3 times 2 is 6. And we're all balanced. We were balanced here, but we did not have whole number coefficients. Multiplying everything by 2 gave us the whole number coefficients, and we are much happier.